I'm going to go over the 4.2 quick check. Now I found this cartoon, and here's a little bear in the water, and he goes, "Help, help, I'm dissolving." But the other bear goes, "But bears are insoluble." And the guy goes, "Well, that's easy for you to say, you're not polar." So one of the ideas here is that something that's polar will dissolve something else that's polar, and non-polar will dissolve non-polar. We call that like dissolves like. And that's one of the first questions that comes up here on our quick check. So write three pairs of substances that would dissolve in each other. So one of the things we have to know, water is polar. Now, what does polar mean? Polar means that there's a positive end and there's a negative end of that molecule. And that's what happens with water, because water, you can see kind of down here, water has a positive end and a negative end because of the shape. And so we have to know that that's polar. So polar things would dissolve polar things. So one choice here would be, say, H2O and HCl. Okay, those would work. Non-polar things dissolve non-polar things. So the C6H6 and the I2, those would work. And the other thing is that polar things will dissolve in, ionic things will dissolve in polar things. So like NaCl, we all know that salt water, NaCl and water, that those would dissolve nicely as well. Okay, I think that we could say AgCl would dissolve in water. It would just be a little bit. And HCl would dissolve in water. We already have that. Okay, HCl and NaCl, they would dissolve. So there would be any polar thing. So these two would dissolve in each other. And then the other polar and non-polars would dissolve in each other. Now, just to help illustrate that, so we're talking about polar molecules because they have positive ends and negative ends. Okay, even big polar molecules, this is sugar, okay, has a lot of little places where there's positives and negatives. There's a lot of O's and H's next to each other. And so the water molecules, being polar, would allow those to separate from each other. But also, when we talk about ionic compounds, like ionic compounds over here is like the KCl. So the KCl molecules, and they're not really molecules, the crystal, are repeating patterns of positives and negatives. And we can see what happens right here is a great example. Here's a positive ion, and the negative ends of the water molecules surround it. And the same way, here's a negative ion, and the positive ends of the water molecules surround it. And that's also happening over here. So these are places showing that ionic substances will dissolve in water, in polar substances like water. Okay, we're talking about concentrations. Now, we're going to probably be talking about these in terms of words, but I think it's easy if you think of these in pictures. So, the idea is how much solute is there and what's the total solution. So the solute here, you can see 4.5, 4.5, 2.25, and you just have to notice that these two are double the amount of that last one. So I drew three pictures, and I drew about 12 dots here, and I drew about 12 dots here, okay? This one is in 400 milliliters, this is in 800 milliliters. So which of these is more concentrated? And obviously this is more concentrated than this one, okay, because this is spread out, so it's more dilute. And the last one here, in the same size, okay, like this one here, I only have half as much solute, so I just drew about 6 dots. And you can see that that's going to be the most dilute. So the least concentrated. So to go from the least concentrated to the most concentrated, it would be C, would be the least concentrated, then it would be B, and then it would be A as the most concentrated. So I would probably write my answer C is less concentrated than B, is less concentrated than A, and that would be a good way to do that question. Okay, molarity. Here we get to an IESA kind of a problem. And remember, IESA is show the information, write the equation, and then we're going to substitute and get the answer. So what is the volume? Okay, so we're looking for volume, molarity, and the number of moles. Okay, so what is the volume? So we're looking for volume. Okay, molarity, we're given that 0.300 molar. And we can see that right there. And we have 0.15 moles. And because we haven't talked about how many grams, you haven't seen grams, we haven't seen mass, okay, either of those clue words, so we don't need to worry about, how much that stuff weighs. This is going to be plenty. Okay, we need to get our equation, so I'm going to sketch down here really quickly my triangle. Okay, molarity is number of moles over liters. Again, that's the definition of molarity. Now what I need volume. I need volume. So volume is equal to N over M, the number of moles, divided by the molarity. So that gives me my equation. So that's the second point. Okay, put in my numbers here. So 0.150 moles and divided by 0.300 liters. Okay, and when we get down, I can see 0.15 divided by 0.3. That is going to be about a half. So my answer here is going to be 0.500, and I'm doing volume, so that means it comes out in liters. So the answer to this, I can make half a liter, 0.5 liters, with the information above. And that's how you do this problem. Let's try another one. How many grams? Okay, since we do see grams in this case, we're going to have to worry about the molar mass of MgBr2. So let's get that out of the way first. That means we have to go back, refer to our periodic table, and I found magnesium over here, found bromine over here. And now I have to remember that magnesium is 2 plus and bromine is 1 minus. Okay, in my problem, it does tell me it's MgBr2, so that's okay. So I need 1 Mg and I need 2 Brs. I look them up on the periodic table. I can see that Mg is 24.31 and the bromines are 79.90 each. Add them all up, and that's 184.11 grams per mole. 184.11, we'll need that. So now let's go back. How many grams? So here I still have the three things I'm looking for. I'm looking for volume, I'm looking for moles, and I'm looking for molarity in my problem. Now I can see right here, here's 0.800 molar. So I have that there. And it's a 200 milliliter solution. Okay, so I'll write 200 milliliters. But the definition of molarity has moles per liter. So I'm going to have to change this into liters. So I'm going to divide by 1,000. And that's going to give me 0.200 liters. So that's the number I'm going to use, 0.2 liters and 0.8 molar. And I'm looking for my moles. That's the only thing that's missing. And I'll go back to my molarity triangle. So molarity equals moles over volume. And since I'm looking for moles, then my equation is going to be N equals M times V. Okay, since these are together here, it's M times V. Now I'm going to go back and substitute. So my number of moles equal my molarity, 0.800 molar, times the volume in liters, so 0.200 liters, and by using my math, I'll see that that's 0.160 moles. Now that is a useful number, but that's not my answer because I went in grams. So now I have to go back and use the number I figured out down here, the 184.11. So my last step is 0.160 moles times, and I want moles on the bottom, because I want those to cancel, and I'm going to use my 184.11 grams on top, and then just going to multiply these numbers. Okay, and I calculate that as 29.4576 grams of MgBr2, and I would probably report that as 24.5 grams of MgBr2. So that's my answer. Okay. Here we are. Our last problem is a dilution problem, and dilution has, as soon as you see, here's a molarity and here's another molarity, and here's a volume, that's a good clue that this is dilution. And dilutions go by the formula that the volume times the molarity in one situation is equal to the volume times the molarity in another situation. And the reason we know that is from the triangle, we can see that the number of moles equals volume times molarity, just like the last problem. And when you dilute something, you don't change how many moles you have. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I dilute that, I just put it into a larger, container. And you can see that since I've spread that out, I've diluted it. So the volume times the molarity before you dilute it equals the volume times the molarity after you dilute it, and that's where that dilution formula comes from. So what I'm looking for here is I have two volumes, volume 1, molarity 1, and volume 2 and molarity 2. And so out of this, then there's going to be three numbers given in the problem. So let's go back. I have a 0.9 molar solution. That's my stock solution. And I also have 0.3 molar solution after I've diluted it. Okay, so how many milliliters of 9 molar stock solution are needed to prepare 500 milliliters of 0.3 molar? And so I have to figure out, well, that 500 milliliters, does that go with the 0.9 or the 0.3? I'm sorry, 9.0, not 0.90. Okay, so 9.0. And the word of is a good clue here. So 500 milliliters of 0.3, then I know that the 500 milliliters goes with the 0.3. So I'm looking for my first volume. So I've got my I, I've got my information, I've got my equation. I'm just going to go back now and substitute in. And so I'm going to say X times 9.0 molar is equal to 500 times 0.3 molar, kind of running out of space. And so I'm going to solve for X. So it's 500 milliliters times 0.3 molar over 9.0 molar. Okay, and when I calculate that up, I get 16.6666 repeating, so I would probably write that as 16.7 milliliters. And notice in here that I did not have to change the liters. Okay, I'm not using the equation of the definition of molarity. It's actually a volume here and a volume here, and whatever units, as long as they match, they're going to cancel. So if I start with milliliters, I'm going to end with milliliters, and that's fine for this problem. So my final answer is 16.7 milliliters, and that's quick check 4.2.